Hey guys, welcome back to my next video in the Math Kangaroo challenge from 2007 for grade 3 and 4. Today we are tackling questions 21 to 24 together. Let's think, solve and level up our math skills. Are you ready? Problem 21. The following three diagrams represent a pattern in the arrangement of the black and white cells. If the pattern continues, how many white cells will be the next diagram have? So we have given three diagrams. They have counted white cells for us. Now, what we have to determine is we have to predict how many white cells will be there in the next diagram. So the best strategy is to count black cells and find the total and identify a pattern in it and see what pattern would be the next diagram. So we have black cells 1, 4 and the third diagram has 9. White cells already given 8, 21, 40. What are the total cells? 9, 21 plus 4, 5, 40 plus 9, 49. Now check the list of the black cells. Do you see a pattern in it? Yes, they increase by 1 and then multiply by itself. So they increase 1 increase to 2, make it multiply by itself gives us 4. 2 increase by 1 which gives us 3, 3 multiplied by 3 gives us 9. So this is what I mean. So 1 multiplied by 1, the next pattern 2 multiplied by 2, 3 multiplied by 3. So what will be the next pattern? Yes, we increase 3 by 1 and multiply by itself gives us 16. Now to check the pattern for the total cells. Do you see some similarity in here? Yes, the total number of cells follows a square number pattern, which is increased by 2 each time. So the 9 is a square of 3. If we add 2 to it, makes it 5. 5 square gives us 25. 25 plus 2 gives us 7. And 7 multiplied by itself or the square gives us 49. Now 7 plus 2 gives us 9 and 9 multiplied by 9 gives us 81. So our next number would be 81. This is how it looks like 3, 5, 7 and 9. Now we have black cells, we have the black cells pattern, we have total cells. What we have to find is the white cells. So we subtract total cells from black cells and gives us the white cells. So we say 81 minus 16 gives us 65. So our answer is 65 white cells for the next diagram, which is option C. Did you get it right? Let me know in the comments. Awesome. You guys are doing great. See you in the next adventure, which is problem 22. Keep up the great work. Let us read problem carefully and mark the key info. The seats on a children merry-go-round are numbered in the sequence 1, 2, 3 and so on. On this merry-go-round, Peter was sitting on seat number 11 exactly opposite Maria, who was sitting on seat number 4. How many seats are there on this merry-go-round? We have a merry-go-round and seat number starts from 1, 2, 3 all the way around. Peter is sitting on a seat 11. Maria is sitting exactly on seat number 4. Now our mission is how many seats are there in total? Imagine we have a merry-go-round in the form of a circle. 2 seats are exactly opposite when they're halfway around the merry-go-round from each other. Peter is on seat number 11. Maria is on seat number 4. This means Peter and Maria are opposite to each other. Now the number of seats between them going in one direction is 5, 6, 7, 8, 9, 10 and 11. This means we have 6 seats in between 1, 2, 3, 4, 5, 6. Since we need 6 numbers on one side, to keep it even, we also need 6 numbers on the other side. So we know that the number starts from 1 to 3 and so on. So our next number would be 1, 2, 3. Now we have 3 numbers here. We need 3 more numbers to set it even. So we have 11, 12, 13 and 14. Wow, we have our answer. The merry-go-round has 14 seats. Correct option is option B. Did you get it right? Let me know in the comments. Awesome. We are now halfway through this series. Next up, problem 23. Keep up the great work and I'll see you in the next challenge. Problem 23. To start, we read the problem, mark it and understand it clearly. So our problem says, how many digits are needed to write down all numbers from 1 to 100? We need to count all the digits used when writing numbers from 1 to 100. Let's break it down into groups to make it super easy. Group 1, the digits which is single. Group 2, 2 digits number. 3, 3-digit number. So first count the digits starting from 1 to 9. They are the single digit numbers. There are 9 numbers. 1, 2, 3 to 9. Each number has 1 digit. So total is 9-digit number. Second group. Numbers 10 to 99. They are all 2-digit numbers. There are 90 numbers from 10 to 99. Each number has a 2 digits. So total digit is equal to 90 numbers into 2-digit numbers gives us 180. Group 3, number 100. This is the only 3-digit number. So one number into 3 digits gives us 3. We sum 9, 180 and 3, which gives us 192. And this is our option D. So how many numbers we have? 192. We have finished problem 23. And now we are going into problem 24, the final one in the series. You have done an incredible job and I'm excited to see how we will wrap it up. Let's keep up the great work and finish strong. Problem 24. A square piece of paper is folded twice in such a way that the result is a square again. In the new square, one of the corners is cut out and the paper is unfolded. Which of the following designs cannot be obtained this way? We need to figure out which of the following designs cannot be obtained by folding the paper twice and cutting its corners. First, let's imagine folding the paper like this and cutting its corner. After unfolding, we should look at this option A, option B, option C, and option D. You can even try cutting a square piece of paper yourself to see the patterns on a sticky notes, for example. So here are the cut squares of the paper design I have done. So you can see that I have folded it and then I cut the corners. Folded it, cut the corners from the center and then unfold it, and I was able to obtain A, B, C and D. So Which one is the correct answer here? Option E. It says that all of the designs can be obtained this way. Let me know if you would like to add anything or need further refinements. If you enjoy solving this puzzle, don't forget to like, share, and subscribe for more amazing challenges. Thanks for watching and keep up the great work. We are on to 2 bonus questions next. Thank you.